So in this scenario, so we are going to see the continuous delivery. Okay. So we know the continuous integration, right? Continuous integration is nothing but, so if you want to automate all the manual process, then that is called as a continuous integration. And coming to the delivery side, if you want to deliver your application into multiple environments, so we already know that, right? So when we go for the organization level, so we are having different types of environment, right? So let's say we have the development environment, and we have the qual environment, and we have the certain environment, and we have the production environment, right? So in this environment, so we are keeping the multiple servers, so more than one server, so more than okay, so more than one server, right? More than one server we need to deploy, correct? So more than one server we need to manage. So you might have one doubt, right? So why we need more than one server? So because of that, so whenever we are doing the any kind of deployments or any kind of configurations in the application level, you need to require more than one server. So more than one server is for high availability. High availability. High availability. So this is very important, guys. Okay. So for more than one server, if you require the high availability, clear na? So we have the developer environment call. If you take say organization by organization, might be the environments might be changed. Environments might be changed, but okay. So if you take any kind of environment, we require more than one server. Let us assume so we are taking 4 servers in any kind of environment, guys. Okay. So this is for server 1. This is for server 1. This is for server 1. And this is for server 2. And this is for server 3. And this is for server 4. Okay. So we have the 4 servers, guys. So within these 4 servers, I want to set up my application, right? Whenever if you want to set up my application, so what are the things are required? So first thing is we need to make ready for softwares, make ready for softwares. Okay. And second one is to get the code, and third one is to deploy them to server, and fourth one is manages middleware services, manages the middleware configuration, manages the middleware configurations. Okay. So manages the middleware configuration. So this is very important, guys. So whenever if you want to make any workspace is ready, and we have to configure all the configurations, right? And the same configurations we need to do one more server, and same thing we need to do one more server. Okay. So like Swan, how many servers are available in the environment level, and we need to make sure to make the consistency in all the servers. So that is very very important. So in that scenario, so how we can able to handle the situation? So how we can able to handle the situation? So as of now everyone is clear. As of now everyone is clear.
Yes.
Are still any doubts?
Yes.
Just ping me in the chat here. Might be your voice is unable to hear your voices. So just ping me in the chat. Good. Right. So now coming to here, the same kind of operations we need to do in the server too. Let us suppose whenever we are doing these kind of configuration, it may take 2 hours. It may take 2 hours, right? whenever if you are doing these kind of operations, it may take 2 hours. So same kind of operations, if you want to take this server also, it may take another 2 hours, right? Or less than more than that. Because see, sometimes you might be noticed in the organization level. So if one developer working fine, if one developer working fine, but the same developer is doing the same kind of configuration, it is not working. So that is based on different types of the configuration. That is based on different types of the configuration. Okay, so which kind of configurations we can say? That should be a operating system configuration, code compatibility, network compatibility, anything, right? So because of that, so it might be having an issue. Because the problem here, so we are doing the same kind of operation, same kind of process for multiple servers. So let's say in tomorrow, if we have a few more, suppose 20 plus servers are available. So it may take 20 to 40, approximately 50 hours we need to spend to set up only the workspace in the servers. Then what was the solution? So here the DevOps engineer will come into the picture. So they are using some kind of concept is containerization. They are using the concept is containerization. So here the DevOps will come into the picture. So DevOps will come into the picture, and to make sure that they are using some kind of containerization tools for manage services. Okay, containerization tool for manage those services. So this is very important, guys. So this is very important. Okay. So how we can able to do that? So this is the packaging, guys. Okay. This containerization tools use the concept called packaging. Whatever the configurations they are using, everything they can make it into package, and the same package we are distributing into different server. That's it. Okay, like how we are sending the goods. Let us assume we have the four server. This server is Dilshuk Nagar, and this is for SR Nagar, and this is KPHP, and this is the BHL. Let us assume we are keeping the four servers in four different location. If I want to sending the goods, so how we can do that? Whatever we can make it everything into the package, right? We can make it within the package, and we are sending them to the container. That's it. That is a good solution. The same way in the applications also, what they can do. So they are going to combine the package. Let us say in the first server. So we are doing all kind of manual activities, right? We are doing all kind of manual activities, correct? So all these manual activities, so we can make it into one image. So here the package is coming to the picture. So to combine all kind of configurations into the single unit. So from that we are sending these packages into the container. That's it. Just we can run here. Just run here. So because of the container, it will run. So here the containerization is the Docker. So the Docker is responsible to convert all kind of configurations to convert all kind of configurations. So here okay, so here Docker is responsible to convert all kind of configurations, right? Docker is responsible to convert all kind of configurations into single unit. So this we can say the package. This we can use the package. So Docker is responsible to convert all kind of configurations into the single unit. This is the package. This is called as a package. Okay, and these packages, Docker is responsible to convert all kind of config to the package, and these packages deliver into number of servers. Number of server. So this is very important, guys. So this process is called as containerization. So the entire process is called as entire process we can call containerization. Entire process is called as containerization. So this is very important. This is very important. So whenever we are using the Docker, so the Docker is responsible to convert all kind of configuration into the single unit, and this kind of package is to send the all pro that is called as a containerization. So this is very important, guys. So this is very important. Here what is an advantage? See, whatever the configurations we are doing in the server, do everyone in the package, right? So within the package itself, it contains the operating system, it contains the middleware services, it contains the server, deployment code, everything will be there. And we are just sending into the images. That's it. So that is an advantage. So delivery is nothing but, so to continuous delivery is nothing but to make sure the consistency in all the servers. Whatever the configurations we are doing, to make sure the consistency in all the servers. So that is called as a continuous delivery. To make the consistency in all the servers, that is called as a continuous delivery. Okay, right. So now coming to the one more tool. So here this is the images, right? So you might having one. Let me send this screenshot so that you guys can understand very clearly. So clear, guys? Understanding about the containerization? Understand about the containerization? Yes. Okay. So this will help us to make sure to configuration all the containerization. So this is very important. Now, right. So, but we have the 4 servers, right? See, we are not using physical, the first important point. So we are not using the physical configurations, correct? So we are not using configurations. Servers, we are not using the physical configurations among the servers, right? But everything is images, correct? So all we convert them to images. So who is responsible? See, who is responsible to do the process? Who is responsible to manage the images? Who is responsible to run the images, right? So that is very important, guys. So here we need to point who is responsible to run the images, right? So here the containers. Okay, so that's why so whenever we are going to the Docker, so Docker is nothing but all the command based tool. Just for every operation we have the commands, right? We have the commands, and even if you want to convert your configurations into the image, that is also having some kind of commands. So we can easily do the process. So this is very important. So how we can do that? Okay. So now coming to the process, guys. So right now, if you see this diagram, so we are doing like this, correct? So we have the server one. Let's take this is the server one, server two, server three, server four, right? So we have the 4 servers: server one, server two, server 3, and server 4, correct na? So we have 4 servers. Now the point is, so within these servers what we did, So we just doing like this, we just creating one image like this, which created image like this. See, please, you might having one doubt, sir, same kind of image or different kind of image? Same kind of image, right? So whatever the configurations, like in within this image itself, it can contains the operating system, and it contains the application code, and it contains the other configuration. Everything will be there. Everything will be there. So all these things we can keep into some kind of storage, that is called as a registry. So even the Docker is having some kind of registry, that is called as a Docker registry. The Docker registries can contains different types of the configuration, different types of the configuration. Right now, what we can do? So Docker registry can contains different types of the images. It is a storage, like how we are Git is there. Git is nothing but to keep our application code. The same way, the Docker Hub is responsible. So I am sending one note here. I'm sending one note here. So Docker Hub is a service to store all images, containerized images. So Docker Hub is a service to store all kind of Docker Hub is a service. Docker Hub is a service to store all kind of containerized images. So this is very important, guys. This is very important. So now, because see, as per this diagram, so this is an image, right? So within the single server, we are deploying image. But why we need a 4 server? Let's keep single server. We can keep the same 4 different images. See, instead of that, if you go to this approach, if you want to this approach, let us say this is the server, right? So instead of the 4 servers, because why we are giving 4 servers? For high availability. But instead of that, see here the high availability is not a server, high availability is applications, correct? Because within the 4 servers, we are deploying the application. Now what we can do, within single server, we are keeping all 4 different images, right? So that is also be possible. See, like this, like this, like this, like this, like this, right now. So like this, we have the 4 different types of application. So now Docker Hub. So with what is an advantage here? So the infrastructure cost is very reduced, right? So earlier we are doing the physical, and one more advantage, guys. Okay, suppose within the single server, if you want to install a number of services, suppose let's say we have the physical laptop, right? So you are install the Jenkins. You are install the Jenkins, guys. So how many Jenkins you need to install within single server? Guys, can you anyone ping me in the chat? So how many servers, how many Jenkins servers physically you need to install? Only one. Okay. So only one servers you need to install physically. But when you go for images, right? Images is nothing but it's a different, right? Identical image, right? So in this scenario, so we need to create a number of Jenkins machine we need to install because of the image. So just we need to run the image, automatically one service will be one more service. Okay, like same kind of application. That is an advantage here. So here also the load balancing will come. So whenever the load is coming to the picture, so automatically it should be distributed like this, like this, like this, like this, like this. Okay, so based on that the load will be distributed, and this is the responsible, guys. Okay, so Docker is responsible to make sure, okay, Docker is responsible to make sure to convert all kind of images, and these images we are running inside the containers. So these are the two responsible will be taking care. Okay, and where we are going to store these kind of images? Docker Hub. And one more tool in the containerization tool, guys, that is called as a one more tool is called as that is one more tool in the containerization tool, that is called as a Kubernetes. That is called as a Kubernetes. Kubernetes is responsible orchestration, guys, orchestration of the containerized applications. Kubernetes is responsible orchestration of the containerization application. So how we can able to do that? How we can able to do that? Let me draw a small diagram. We can discuss very clearly. So let us take, we have the four servers. Let us take, we have the four servers. Server 1, server 2, server 3, and server 4, right? We have the four servers. So my requirement is, so we need to deploy my application at a time. So we need to make the consistency, and we need to make the consistency, and we need to deploy our application, and we need to manage the configurations as well. Let us take, when we deployed any kind of image, automatically my image is up and running. Let us suppose 1 minute, guys. Yeah. So let us suppose, okay, if the image is down, so what you need to go to the manually, you need to restart the image. And let us suppose if you are getting the load, but as of now, so we are having the load of 50 users. So all of sudden we are getting the more load. Okay, all of sudden we are getting the more load. Then how we can able to handle the situation? All of sudden we are getting the more load. So how we can able to handle the situation? So that is very important, guys. Understand? So all of sudden, if we are getting the more load, all of sudden we are getting the more load. So we need to make sure the auto scaling, right? We need to scale up automatically. And when the load is not available, we need to scale down automatically. Who is responsible? So whenever we are converting our application into the containerization application, so the Docker is responsible only for two things. Okay. So one is for to convert all configurations into the images, and second one is we need to run inside that. So that's it. Nothing will be there. Nothing will be there. Then who is responsible to take care of all the configuration? So that will come under Kubernetes. That will not come under Kubernetes. The Kubernetes will help us the Kubernetes will help us to orchestration of the containerized applications. Okay. So now let us create one server. So whatever the servers are available, everything can able to orchestrate. So this is the server. Okay. That is cluster, guys. Cluster is nothing but to convert all kind of configurations, to convert all kind of conflicts like this, like this. So group of nodes working together as a cluster, that is called a cluster. So this is very, very important. Use as a DevOps engineer, this kind of configurations or this kind of terminologies are very, very important. So once you join your organization, okay, when you are working on these kind of containerized applications, so these clusters will come into the picture when you go for the Kubernetes. So here, so this is called as a master server. This is called as a master server, right? This is called as a master, and this is called a four different types of the server. Okay, this is the web server 2 and web server 3, web server 4. So one is for web server 2 and web server 3 and web server 4. So this is very important, guys. So one is for master. Master is nothing but web server, right? So like this we can able to master. So web server 1 and web server 2 and web server 3 and web server 4. So this is very important, right? So now the point is, so already, see, we already having the image, right? So Docker, what they can do, Docker is keeping. So let us take, this is your Docker hub. Let us take, so this is your Docker hub, right? So this is your Docker hub. This is your Docker hub, and within the Docker hub we are keeping the application, correct? we are keeping the application. This is our application. So let's say this is called as a my app, okay, and this is called the Docker Hub. But here, who is responsibility who is responsibility to deploy? So, but here the Kubernetes is responsible. 1 minute, guys. Clear, guys? So now what we can do? Now what we can do? So whatever the application, right? This is the master. So this master is responsible. We can write some kind of script here. So here I told you, right, YAML is a like kind of template, right? So let's say, so this is an application, this is a API version. I'm just doing like this, API version some dot v1. Okay, so like this. So image, so this is the image, right? My and if you have the version 1, the version also we can do like this, guys. Okay, so this is a script, we are just running the script. So because here also Kubernetes also command based, okay, Kubernetes also command based. So to orchestrate all kind of Kubernetes, so here what is the responsible for this Kubernetes is responsible, kubernetes is responsible it is responsible for scalability, availability, and deployment. Scalability, availability, and deployment. The Kubernetes is responsible for scalability, availability, and deployment of your containerized applications. Okay, deployment for our for containerized applications, right? So Kubernetes is responsible for scalability and availability and containerized applications. So this is very important, guys. So this is very important. Now, whenever we are executing this command, automatically the Kubernetes will push all kind of applications into here. The Kubernetes run it. sorry. Okay, so now automatically, see, this is the master, right? See, please make sure master is responsible to push all kind of configuration. Master is responsible to deploy all kind of configuration. So whenever we are doing here, right, whenever we are doing automatically, it should be deployed like this. It should be like this, like this. Got it, na? So any number of application automatically it will be deployment. So the master will push all kind of applications to that. And suppose if we, in between, if we get any issue, let us assume we are having one issue. Okay, we are having one issue. No problem. Even if we get any issue, let us suppose all of a sudden your server is down. Don't worry about it. Automatically it should be recreated. Automatically it should be recreated. So like this. So this is how we can able to working on the Kubernetes. So this is the heart of the DevOps, guys. Let me tell you one thing. See, Docker, Kubernetes, AWS, and Ansible. Okay, so these four technologies or tools are very important. So in the DevOps, okay, if you see these resumes, okay, so especially Docker and Kubernetes. So this is the trend in the market. Okay, that's why I'm explaining each and everything slowly, right? Each and everything. So what are the configurations? How it should be there, right? Now we are going to combine typical CI/CD process. So whatever the CI configurations we are learning, and whatever the CD, right, Docker and Kubernetes, everything we are going to combine, and I will show you one clear diagram so that you can understand. You can just think about the high level. If anybody asking that organization level, what is an architecture and what is the flow of your application, so we can see like this. What is the flow of your application? You can see like this. So this will help us to do the process. This will help us to do the process. So this is very important. This is very important. This is very important. Now coming to here. Okay, now coming to here, let me typical CI/CD process. Let us assume, just assume for yesterday diagram and for today diagram. Okay, CI/CD process. So this is called as a CI/CD process. CI plus CD process. Okay, so first what we can do, so for every configuration, for every, from registry wise, right, from registry wise, anywhere we have some kind of registry, we have some kind of registry where we can able to keep our application. So that is very important. Now the point is first, usually we are keeping our application code into the git, correct? We are keeping our application code into the git. So let's take, so this is your git, this is your git. Okay, so here to keep application code, it is to keep our application code. So next one is we are using the Maven, correct? Next one is we are going to Maven. Sorry, yes, this is called as a Maven, and this is called some kind of artifact tools. Okay, some kind of artifact tools or JFrog or Nexus, anything else, anything. Okay, so here I am taking the Docker. Here we are seeing the Docker hub. Okay, so here we are having the master server, right? So for the environment, right, cd is nothing but you have to deliver your application to 4 different types of server: server 1, server 2, server 3, and server 4. Okay, so 4 different types of server: server 1, server 2, server 3, and server 4. Server 1, server 2, server 3, and server 4. And one more important point here, one more important point we need to keep like this. One more important point here to keep like this. So this is called as a master, correct? So this is called as a master. I can differentiate like this, you can understand clearly. And here the Jenkins will come into the picture to automate all the process, right? Whenever the developer commit the code, right? So whenever the developer commit the code, automatically this process will be executed. Whenever the developer commit the code, automatically this process should be executed. So this is very important. Now coming to here, this is called the Git, Maven, and this is called the Nexus and JFrog. Nexus or JFrog. So any sonar, anything guys, okay, anything, some kind of middleware kind of tools, we are using some kind of the performance of the code or anything, okay, right. So here I can take, this is the docker docker, and this is called as a docker hub, and this is called as a master. So we can say the Kubernetes master, okay, Kubernetes k master, and this is called as a k master, and this is called as worker node. So web server 1, web server 2, right? So these are the actual servers, web server 1, web server 2, web server 3, and web server 4. Right. So we have the web server 1, and we have the web server 2, and we have the web server 3, and we have the web server 4. So this is very important guys. So see the automation. So what is the responsible here is the Jenkins, right? Jenkins is responsible to take the process. Jenkins is responsible whatever the manual task, everything we can make it like this. Everything we can make it configured in the Jenkins, okay. So let us assume I can differentiate like this, okay. So first thing is whenever the developer commit the code, okay. So Jenkins is simply nothing but continuous integration is simply nothing but to integrate all the tools guys, whatever the tools we are using. So this is a typical CI/CD flow, so how it works? So to get the code from Git, okay. Second process to come to validate and packaging the project. So so don't worry about it. Whenever we are going to discuss each and every tool, you will get a most of the thing. But right now I'm just giving the overview. So these are the tools will be there, and these are the process will be there. These are the tools will be there. These are the tools will be there, and these are the process will be there. So this is very, very important. And third one is, so we need to, first one is to get the code from the Git and validate the project. Next one is to send packages into Artifact tools. Fourth one is, okay, fourth one is, and we need to check the, to convert images, send them to Docker Hub. And fifth one is, so executing, send, deploy them into master, Kubernetes master. Deploy them into the Kubernetes. That's it, guys. So whatever the manual things, so we are doing here. So everything it should be automated. So everything it should be automated like this. So now what I can do? Now what I can do? Let us make it like this. I will show you clearly. Okay. So first, whenever we are getting the code, this, like this, like this, like this, and after that it should be like this, like this, like this. Okay. Right. Now I am going to so automatically the master will be, okay. So clear. So now I am going to give overview on each and every tool. So what is that? Okay. So first thing is, so first thing, to keep the application code, keep application code. Okay. And Maven to compile and packaging the project. So packages might be var file, var or jar packages. Okay, so next one is the nexus. What is the responsibility for here? To store artifacts, to store packages into artifacts, to store packages into artifact. So so this is very very important, to store packages into the artifact. Nexus is nothing but to store packages into the artifact. So this is how we can able to working on that. And one more thing guys, okay, one more thing, and to check the performance, to check code performance as well. Code performance, while seeing the diagram you can understand 50% of the device tools is covered. Okay, performance of code, we can say the application, right? And docker is what is the responsible, you already know that, right? To convert all our configurations into images, and then then these images sending sending them into Docker Hub. Okay, so let us take, so this is your application. Let us take, this is your application. This is your application. Okay, so this process is called, this is take, this is your application, my app. Okay, so this is the application. So next one is what we can do, Kubernetes master. So here the responsible to deploy Docker images to deploy images into, or we can, instead of that, to deliver. Okay, instead of the deploy you can simply say that deliver images, to deliver images into different types of servers. Automatically, so this should be deployed like this. So like this, correct na? So it should be like this, like this, like this. So this is the typical CI/CD process, guys. This is the typical CI/CD process in the world. This is the typical CI/CD process in the world. Okay na? So this is the typical CI/CD process in the world. So Git, okay. So see, up to the testing guys, up to the testing, if you want to, these three tools, Git, Maven and Jenkins, Nexa, JFrog, Socra, up to the testing, up to the, this process is called the continuous integration. Okay, from Docker onwards, this is the delivery. Clear everyone? So now I'm going to sending this diagram to you, so that while seeing the diagram you can easily understand, guys. While seeing the diagram you can easily understand who and what was the process and how we can able to do that. What was the process and how we can able to do that, right? Okay, so this is how we can able to working on the organization level. Any questions, Murali, from your end? Any questions, Murali?
Jenkins, Kubernetes.
Just ping me in the chat. Okay, so Harsha, any questions? Okay, fine. So this is very important. Okay, so for next session what we can do, we are going to see the configuration management and continuous monitoring. Okay, so these are the another two pages in the DevOps. So right now the continuous integration is completed, continuous delivery. Yeah, Kubernetes is nothing but orchestration morally. See, right now what we did, we just created, right? We just created Dockerized images, right? So when we are coming to the Dockerized images, so this is the response, Kubernetes is responsible to manage these kind of Dockerized images. Okay, so when we are pushing into different server, okay, suppose manually, otherwise what we need to log into each and every server, we need to log into each and every server, then we need to deploy the Dockerized images. But the Kubernetes, what they can do, whatever the script we are writing in the master, automatically the Kubernetes will deploy the images into all the servers at a time. So that is called as a clustering. So clustering is nothing but to convert all kind of configuration, to make sure to convert all kind of configuration. So this is very, very important to make sure and clustering all kind of configuration. So here what happened, suppose we are scalability, okay, scalability, high availability and deployment, all the things will be taken care of by Kubernetes. Suppose once you deployed your application, okay, all of a sudden your application is down, the Kubernetes is responsible to restart the application, okay. All of a sudden Kubernetes is responsible to restart the application, and let us suppose we are getting the load. So all of a sudden we are getting the scale up the load and decrease, that should be also taken care by Kubernetes. Got it, Murli?
Yeah, got it అండి. Got it
But
అండి.
the two things, Docker is only for creation of the images. Kubernetes is nothing but orchestration. Orchestration of scalability, availability, deployment, make the consistency.
ఓకే. మనకి ఏ సర్వర్ డౌన్ అయిందనేది మనకి ఇక్కడ
Both are
అర్థమైపోతుందా?
using the managing the image, Dockerized images only. Clear, Murali?
ఓకేనండి. అండ్ హలో వినపడుతుందండి మీకు? హలో.
Yeah. I will check with. Yeah, exactly. Yeah, exactly. So I will try to check it once. I'm not sure why it is happened. So I will try to check it once. Okay, na? So I hope tomorrow it will work. Because till yesterday it is working fine. I'm wondering why it is not happened. Fine. Thanks everyone. Bye.